particular question number 4, okay, we have prenol, a naturally occurring organic molecule found in many fruits. It contains both alkene and alcohol functional group. Okay, so you have alcohol and you have alkene. Now, I have done this question previously, so I actually took some of the information that I want to highlight to you. Okay, maybe later I will show you. Okay, what are the reactions that you need for alkene? What are the reactions that you need to know about alcohol? Okay, so I have actually written over here. Okay, this one. It's not going to be enough to just when I just simply go through all this. It's definitely not going to be enough. So in order to actually revise on this, okay, I have actually given you a link in your WhatsApp group. Okay, so please actually check. Okay, I have done video, okay, in this channel. Like the BBSPIK chemistry channel. Okay, you can see that some of the things, okay, you can actually revise directly from there. But for the reactions of alkene, we have combustion, we have hydrogenation, okay, using nickel at 140 degrees Celsius. Reaction with steam, okay, you can see the conditions are there. Reaction with concentrated HX, it means HCl, okay, HBr, HI, okay, under room temperature. Reaction with X2, okay, that's going to be reaction with bromine, okay, Br2, Cl2, and so on. Okay, it's possible to break the double bond. We do also have alkene undergoing oxidation. There are two types of oxidation: hot concentrated potassium permanganate acidified, and also dilute cold potassium manganate, okay, acidified. And the last one is addition polymerization. Now for alcohol, okay, I have actually written somewhere here, okay, hold on. I will share this document. You can actually just go through this document as well. Okay, but I just wrote a summary. Okay, so here for alcohol, you have combustion. Okay, you have reaction with ACl, SOCl2, PCl5, PI3, okay, PBr3. Okay, so all this I have actually summarized over here. Okay, number 3 is going to be reaction with sodium, esterification. Then after you do, you get the ester, you can do hydrolysis. Okay, we have two types of hydrolysis: acid hydrolysis and base hydrolysis. Alcohol can undergo dehydration as well. So we have 3 types of catalysts that you can use. You can read over there. And then we also have oxidation reaction of alcohol, okay, using the oxidizing agent potassium manganate and potassium dichromate. So I've summarized all this. Okay, of course I cannot actually go through everything over here. Okay, even I have actually summarized a little bit about carbonyl compound and so on. I will just touch a little bit over there only later when I do this question. Okay, but now, okay, you have this question over here. They say that prenol can be formed by the reaction of G, okay, with sodium hydroxide. So this is G. So this G is going to react with sodium hydroxide. Okay, sodium hydroxide. So I want to actually find out, okay, what are going to be, okay, what are the mechanism, okay, for this reaction, okay, of this compound, okay, which is going to be halogenoalkane. You see the Cl, okay, is going to be changed into OH. Okay, it's going to be changed into OH. So I need to actually write down the mechanism of the reaction that is going to actually happen over here. Now, can someone help me with the type of mechanism that we are looking for? Okay, in this case, we are looking for halogenoalkanes is reacting with halogenoalkanes is reacting with NaOH. It means the OH is going to replace the Cl. So Lavi, can you tell me what type of mechanism that we are talking about over here? Halogenoalkane.
Nucleophilic substitution.
Very good. Okay, nucleophilic substitution. We are talking about nucleophilic substitution. Now, this one also, okay, under nucleophilic substitution, okay, we have SN1 mechanism, SN2 mechanism. We'll go into that later. Okay, but let's actually focus on this. Okay, here, okay, we want to actually find out, okay, what is going to be happening, okay, when you have NaOH. Generally, they want you to include all the relevant charges, partial charges, lone pair, and curly arrow. Okay, so if I want to actually show this, I think first of all, I need to actually show that, okay, this is going to go over here. The electrons from the chlorine, okay, the electrons between the carbon and chlorine, they will actually go towards Cl. So this one is going to actually become a partially negative charge, and this one is going to be partially positive charge. Okay, now, so you have this situation over here, and the next situation is going to be you have the NaOH. So here, okay, you don't see any Na. So what I do is I will separate. Okay, so for example, NaOH is Na plus, OH minus. Okay, so since they are separated, there is going to be OH with a lone pair of electron. So I'm going to actually put OH with a lone pair of electron. If you want, you can actually put the Na plus over here, doesn't matter. So what is going to happen over here is this is nucleophilic substitution. Okay, so nucleophile, okay, they are going to be attracted, okay, to the positive charge. Okay, so it's going to actually, this is nucleophile, they are going to go towards there. Okay, and then, okay, what's going to happen? I think here they didn't actually give us the space to write. So what is going to happen, okay, is either, okay, you can have an intermediate being formed, okay, or without the intermediate, okay, you have the carbocation and then it will split. So they didn't ask us about that. So it's okay, you can just leave it like this, okay. So we have all the relevant charges, positive, negative, done. Okay, if you want, you can actually put it over here rather than putting the OH minus over there. You can actually put it minus here. Okay, so that's going to be the relevant charges. Partial charges I have written just now. Lone pair, you can see the lone pair for OH minus, and then the curly arrow, okay, the movement of the lone pair of electron. Okay, so this one all done. Okay, I think it's good enough. Okay, it's good enough. Okay, then the last one, I think towards the end, if you want to include the Na, so it's going to be plus NaCl if you want to write down. Okay, but I think if you don't write it down also, it's still okay. Okay, still okay. The Cl will come out and then will join with the Na plus, and you are going to get the NaCl. Okay, so therefore, okay, it's complete. Okay, now the next one, okay, is going to be phenol. Okay, phenol reacts with steam, okay, to form a mixture of 3 isomers. So let's actually have a look at phenol over here. So this is phenol. So I will actually bring the phenol so that we can see it more clearly. Okay, clearly. Okay, so I brought it over here. And then they say that it will react with steam, okay, to form a mixture of 3 isomers. I think it's understood whenever something is reacting with steam, okay, of course, alcohol cannot react with steam. So we need to know that the double bond, okay, the carbon-carbon double bond is the one that is going to be broken, okay, when it's reacting with steam. And just now I have mentioned that there is going to be the conditions, okay, where when you have this reaction with steam, what are the conditions? Okay, maybe can we have Victoria? Can you tell us or recall what I mentioned about reacting with steam, alkene reacting with steam? What are the conditions?
I already forget, sir.
Okay, so have a look over here. So this one, okay, this one. So it's going to be the reaction with steam, 330 degrees Celsius, 60 atm, and phosphoric acid. Okay, please actually remember this. Okay, we are learning this so that we try to cover a lot of. I think this is a very good question because in this particular 17 marks question, okay, they have actually covered a lot of things in AS syllabus. Okay, so you can use this question to learn everything actually. Okay, so this one, okay, 330 degrees Celsius, 60 atm. Okay, 60 atm atmospheric pressure, phosphoric acid. Okay, phosphoric acid, concentrated phosphoric acid. Okay, so what is going to happen generally is going to be the double bond is going to be broken. So the water, okay, H and OH, one of the H will come to one of the carbon, another OH will go to another carbon. So if I write down like this, C, the double bond is, let's say, imagine it's already broken. I bring the CH3 over here, and then H, and then CH2OH. Okay, I can have two conditions or two ways where this reaction can actually happen, take place. Okay, whereby if I paste it over here, okay, I will have a situation where I'm going to have the H coming over here, and then the OH coming over here. Okay, the double bond is broken. Or I can have the OH coming over here, and then the H comes over here. So you have two conditions over here, okay, when you are reacting with the steam, okay. But okay, they have mentioned that they have three isomers, but I'm confused now. If you have, okay, if you have this reaction, how come suddenly there are three isomers? So I need to actually find out, okay, which one, okay, will give me any additional isomer. So I don't see any double bond over there. So definitely there is no cis and trans. The only thing that I can think of now is going to be whether there is any optical isomerism. Now, if I put A and B, okay, can someone help me to identify which one contains optical isomerism or any kind of stereo isomerism? Okay, optical isomerism. I'm looking for optical isomerism. Okay, so Nicole, Trisha, can you help me to identify which one has optical isomerism over here?
I'm not sure, sir.
Okay, Arneta, can you tell me, in order to get optical isomerism, what do I need, or what am I looking for?
A.
Okay, it's A. So can you actually tell us how do you identify A having optical isomerism?
The chiral atom is the carbon on the right.
Okay, that's going to be a chiral center. Okay, a chiral center is something that actually a chiral center, the carbon that has four different groups being attached to it. So you can see that if you have, okay, this molecule, okay, if I put this dot over here, you can see that, okay, that carbon is being attached to four different groups. Okay, one different group, another different group, another different group. Okay, this entire thing is another different group. Okay, so you can actually see yourself. Okay, okay, that is going to be a chiral center. So once you have a chiral center, they are capable, okay, to actually have a mirror image, some sort of a mirror image. Okay, so that is going to be the optical isomerism. Okay, but for B, okay, you can see that they do not have a chiral center because any carbon that you choose, okay, they have two same groups already. So it means this one, okay, this A have two variations, okay, because of the optical isomerism. Now, the next step, okay, now I identify already J, K, and L. Now, they say that J, okay, when J, one of the isomerism, if it is heated with the excess acidified potassium dichromate, it forms an organic product, okay, which shows no reaction with 2,4-D NPH. Now, when you have, okay, this thing, okay, you see all these are alcohol, yeah, okay, you can see they are alcohol hydroxyl compound. Now, this hydroxyl compound, when you actually react with acidified potassium dichromate, there's only one reaction that can actually take place, which is going to be what, Shane? What is the type of reaction that we have when alcohol reacts with acidified potassium dichromate?
Is it substitution?
No. Okay, no. So that is actually oxidation, yeah. So Shane, so please actually revise, okay. Everything is actually within your reach, okay. It's not something that you need to actually open your book and learn. Okay, please actually revise reaction of alcohol. Okay, this is the part that I'm talking about. Under oxidation, okay, alcohol can be oxidized depending on what type of alcohol that we can actually talk about. If it is going to be a primary alcohol, they will be oxidized to become aldehyde, further oxidized to become carboxylic acid. Secondary, they will be oxidized to become ketone, but tertiary cannot be oxidized. Okay, please actually remember this. So now coming back to this question. Okay, so of course I'm actually oxidizing this. Okay, I'm oxidizing this, but okay, they say that the product that you get, okay, you can either get carboxylic acid, okay, if it is primary, or you can also get ketone, okay, if it is going to be secondary. So now, okay, they say that this product, okay, the product that you get has no reaction with 2,4-DNPH. Okay, now, Justin, can you tell me 2,4-DNPH is used for what? What is the function of 2,4-DNPH?
To detect aldehyde and ketone.
Yes, very good. Okay, to identify, okay, whether there is going to be a carbonyl compound, aldehyde or ketone. Okay, so 2,4-DNPH also, yeah, I have actually written over here a little bit notes for you. Okay, this is going to be 2,4-DNPH. So if you have, okay, any kind of let's say aldehyde or ketone, okay, they will give you a deep orange precipitate. So how to actually do that? I think you need to know how to actually draw this first, okay, and then you need to actually react. Let's say, for example, I'm actually reacting with a ketone, R1 and R2. So what's going to happen is the hydrogen and oxygen, they will go out to give you water, so plus water, and the resulting compound is the one that will give you the deep orange precipitate. So if I draw, I will get something like this: NO2, NO2, and H joined together with carbon, and then there is R1 and R2. Okay, this is going to be the one that will give you the deep orange precipitate. Okay, so please remember this. Okay, you need to know how to draw this. Okay, I will actually share this later. Please actually go through all this. But anyways, okay, when you have no reaction with 2,4-DNPH, it means we are looking for carboxylic acid. Why? Because carboxylic acid, they do not show any reaction with 2,4-DNPH. Ketone do show. Okay, aldehyde do show. So it means we are looking for any compound, okay, after you oxidize, either A or B, after they oxidize, they actually give you carboxylic acid. Okay, they need to give you carboxylic acid. So I need to find out, okay, I need to find out which one only gives me, okay, carboxylic acid. Okay, so there is no reaction. Okay, there's no reaction with 2,4-DNPH. So if I look over here, I will see that, let's look at A. Okay, when I look at A, I know that for this alcohol, okay, for this alcohol group, this carbon is attached to 2 hydrogen, and then the rest of it is going to be the R group. Okay, this carbon, yeah, this carbon is attached to 2 hydrogen group, and then the rest is the R group. Okay, so this one, this alcohol is known as primary alcohol. Okay, it's primary alcohol. And let's actually have a look at this alcohol. This carbon is attached to one R group and another R group. So this is a secondary alcohol. So it means that, okay, when I oxidize, I am going to get a carboxylic acid here. And I'm going to get ketone over here. Now, if I have A, okay, if I have A, it means I know that there is 2 isomers over there as well. Now, for these 2 isomers, okay, do you think, okay, they will give you a positive reaction with DNPH, 2,4-DNPH? Shane?
What, sir?
Do you think, okay, for A, any of these 2 isomers over here, do you think that they will, after they get oxidized, okay, after they get oxidized, which is you are going to give you carboxylic acid and ketone, do you think that they will give you a positive reaction with 2,4-DNPH?
If carboxylic, sir.
In this case, in A, like for example, you know that this part, they will actually give you the carboxylic acid, right? You know that
Yeah.
they will be ketone. Now, presence of ketone, will it be giving you a positive result with 2,4-DNPH?
Ketone, yes.
Yes. So it means that, okay, can A be the answer? Definitely cannot. Okay, because they have mentioned, okay, when you do this, the product, okay, must show no reaction. Okay, the product must show no reaction with 2,4-DNPH. Here, they will show you the reaction. So definitely this is not going to be the answer. So let's actually have a look at B. Yeah? Okay, so B might be a possible J. Okay, might be possibly J. Why? Okay, let's actually check. Okay, this is going to be carbon, hydrogen, hydrogen. So this carbon is bonded to only one R group. Therefore, this is a primary alcohol. And if I look at this, okay, this alcohol is bonded to the carbon, one R group, another R group, and another R group. This is a tertiary alcohol. Now, when I oxidize this, I will actually oxidize the primary alcohol, okay, to become carboxylic acid. When I oxidize this, there will not be any reaction. Tertiary alcohol cannot be oxidized, okay, cannot be oxidized. Now, so the final answer, I will actually have carboxylic acid only, okay, a carboxylic acid only, and the alcohol group. Now, will I get any positive results when I react with 2,4-DNPH over here, Aneta? Aneta, do you think there will be a reaction?
In J,
Yes, if it is for B, yeah, if it is J. In this case, there is carboxylic acid and there is alcohol. Do you think there will be a positive result over here, 2,4-DNPH? The signal is not clear, yeah?
no.
Yeah, definitely no. Yeah, definitely no. Okay, so it's actually carboxylic acid. Okay, they do not give you the reaction with 2,4-DNPH. Alcohol, definitely no reaction with 2,4-DNPH. So we can confirm that this is going to be the structure of J. So when they say draw the structure of J, okay, you can draw anyway. They didn't actually specify how you need to draw. So if you want to draw it this way and you want to just leave it like this, I'm still fine. Okay, so that is going to be the structure of J. Okay, this is J. Okay, the rest you can actually ignore. Yeah, so that is J. Now K and L. What are K and L? Okay, this one definitely either K or L. Okay, so if I actually put the K and L, okay, let's say I bring them over here. I'll draw CH3, CH3, and then H, CH, CH2OH, and then OH. Okay, now this is from here. I know that this is going to be K or L. So to make it easier, I have drawn over here. So K and L are stereoisomerism isomers, okay, with molecule of C5H12 O2. Okay, K and L both react with heated, okay, with excess acidified potassium dichromate to form M. Okay, now it means again, okay, they say when you heat them, okay, with this oxidizing agent, they will form M. So let's actually try to oxidize this. Okay, so this one again, this is secondary alcohol. If you look at this OH, yeah, okay, the carbon attached to it is going to be, there's two R groups. Okay, so that is going to be secondary alcohol over here. And this OH, the carbon attached to it is only going to be having one R group. Okay, this is going to be a primary alcohol. Now, what I need to do is when you form, okay, the M, Okay, so let's actually try to form the M first. Okay, so here you will have CCH3, CH3H. When you oxidize a secondary alcohol, you will get a ketone. Just put like this. Okay, this is the ketone. When you oxidize a primary alcohol, you will get a carboxylic acid. Okay, you just put this. Okay, this is M. Okay, I found what is M. M forms an orange precipitate with 2,4-DNPH. Of course, yes. Okay, because of what? Okay, not because of the carboxylic acid. Take note. Okay, it is going to form because of this. Okay, the ketone group. Okay, the ketone group. Now, give the structural formula of K and L. Okay, structural. They mention about structural. Now, when you write down the structural formula, be very careful. The carbon is attached to 2 CH3. So I will put CH3 bracket 2. And then carbon, this carbon has hydrogen, done. And then you have C. And this C is bonded to H and OH. How do I show it's going to be H and OH? You can either put a bracket OH first, then H, or you can put H and then bracket OH. Basically, the carbon is attached to hydrogen and OH. Done. And then you have CH2, then you have OH. This is writing the structural formula. Sometimes they'll ask you to draw structural formula, but again, when they say draw also, it's the same thing. Okay, so this is going to be K and L. Name the type of stereoisomerism shown by K and L. Just now only we have identified the type. Nicole, Trisha, what is the type of isomerism that is shown by K and L because of the presence of chiral center? Nicole?
Yes, sir.
What type of isomerism
I'm
that we
not-
are talking about?
I'm not sure, sir.
Okay. Gabriela, Nicole?
Optical, sir.
Yeah, it's optical isomerism. So it's a stereoisomerism. Yeah, optical isomerism is a stereoisomerism. Geometrical isomerism is because of the double bond that is going to be cis and trans. Okay. Now give the balance equation to represent this reaction. Okay, when you have this to form this. Okay, so if you have this, I think no need to actually worry so much because you no need to draw. Okay, you can say that the K is changing to M. So you just need to put C5H12O2. So plus you put a bracket O like that, and then you put C5H8O3. Now, in order to solve this, okay, the easiest method is to look at the hydrogen 12 and 8. Okay, of course, you need to have another 4 hydrogen. So this 4 hydrogen comes from in form of water. Okay, so you need to put 2 so that it's going to be 4 hydrogen, is balanced. And then when you look at the oxygen, there's 2O and then 3O on the right hand side. So it's going to be total 5 oxygen. Okay, total of 5 oxygen over there. So if you want to get that 5 oxygen, okay, how do you get the 5 oxygen? 2 oxygens are there, so you just need to put 3 over there. So it's balanced. Okay, so no need to think so much on this. Okay, do I need to write the the states and so on? For this question, no need. Okay, for this question, no need. Okay, phenol, okay, contains an alkene functional group. Okay, fine. Now, describe a chemical test to confirm the presence of alkene functional group. It means the presence of carbon-carbon double bond. Okay, Jason, how do you actually identify carbon-carbon double bond? What is the chemical test?
Decolorization of bromine.
Yes, okay. React with bromine, okay, bromine, okay, react with bromine. So you can put bromine water, okay. So they will actually give you the color change from orange, okay, to colorless. So just memorize, okay, there are ways how you can actually identify certain groups, okay, especially when we are talking about carbon-carbon double bond, okay, you test that using the BR2. Okay, let's actually, let me actually check, okay, whether you still remember this. How do you test for hydroxyl group? It means how do you test for alcohol group? Any ideas, Charlton? How do you confirm presence of alcohol group? Charlton,
Forget.
forget. Okay, don't forget. Yeah, please actually check everything. Yeah, so it's actually your exam is coming soon. Okay, when you are checking for alcohol group, okay, this one I have even written over here. Okay, let me look for it. For alcohol, okay, you can see here, I have written over here, PCl5 is a test for alcohol. Okay, why? Because if you have ROH, okay, when I react with PCl5, okay, Jody answered the other day last time, okay, you will get RCl, okay, plus POCl3 plus HCl. Now, this presence of HCl, the white fumes of HCl, is a confirmation that, okay, when you have white fumes of HCl, it's a confirmation that there is an hydroxyl group over there. Okay, this is a definite test, okay, for alcohol. Okay, so we have a lot of tests. Okay, please actually identify all these tests as well. How do you test acid? Okay, so I think you know by now. How do you test acid? Probably you test with sodium metal. Okay, so it will give you, if there is a effervescence, okay, then you can test the gas. If it gives you the pop sound with lighted wooden spleen, that's hydrogen. So definitely that is acid. Acid reacts with metal. So something like that. You need to actually understand all this. Okay, in this case, okay, how do you test? Yes, I just mentioned to you. Okay, you test using the PCl5. Okay, now let's move on. Phenol can be polymerized to form polyphenol. Draw one repeat unit of polyphenol. Okay, so phenol, okay, this is phenol. Okay, let me actually bring it over here. So I want to actually draw, okay, one repeat unit. I think to draw this quite simple. Okay, the double bond will be broken. Okay, it will go to this side and this side. And then this one, you just put CH3. Okay, CH3, H, CH2OH. Just leave it like that. Okay, the double bond is broken. So only one repeat unit. If they say two repeat unit, then repeat it twice. Okay. Do I need to put a bracket and then N? No need. Okay, no need. Okay, next. Okay, isophenol is also a structural isomer of phenol. So they have this another phenol over here. Now here they actually mentioned about this reaction. Okay, they react with H2 and Ni. Okay, so let's actually discuss further. Okay, what do you think will be the reaction that is happening over here, Lavi? H2 and Ni. Which one will react? Carbon-carbon double bond or alcohol?
Alcohol.
No.
Carbon.
Okay, this one is what we call as hydrogenation. Okay, so hydrogenation, okay, the double bond. Okay, if nickel is actually the catalyst. Okay, the catalyst, and then one thing they didn't mention is 140 degrees Celsius. So 140 degrees Celsius, you can see over here. I mentioned over here, hydrogen, nickel, and 140 degrees Celsius. So if you do this, okay, the carbon-carbon double bond, they will be broken. They will change from alkene to become alkene. Okay. So that is actually what is happening over here. So it means that the double bond, you can see there is double bond here. There is no double bond. Okay, it's already broken. Okay, it's already broken. Even if you mention it's alcohol, doesn't make sense just now because there is OH and still OH is there. So just be careful. You can actually take more time to answer this, but it's okay. Okay, now you identify this is going to be hydrogenation. Okay, hydrogenation. Now, after hydrogenation, you only have alcohol over here. This is alcohol. Now, this alcohol, okay, when you actually react with potassium dichromate heated under reflux, let's actually find out what type of alcohol is this, okay? So you can see that there is going to be one R group, the carbon attached to OH. So this is a primary alcohol. Now, when you have primary alcohol, of course, they will be changed into carboxylic acid, okay? So this is carboxylic acid. Now, this carboxylic acid, when you heat under reflux with alcohol and sulfuric acid, what happens? Okay, definitely this is going to be esterification. Okay, how do I know it's esterification? They already mentioned it's a sweet smelling liquid. So definitely this is ester. Okay, give the name of N. Okay, now this one quite simple. If I want to give name of something, if you're still confused, please put all the carbon. Okay, please put all the carbon. So it's going to be 4 carbon, OH, and then there's another carbon over there, which is going to be the CH3. So if I want to actually name them, the longest carbon chain that I have is butan, okay, or butanol, okay. But this is going to be OH attached to carbon number 1. So this one is butan 1-ol. Now, this butan 1-ol has a methyl group. Carbon number 1, carbon number 2, carbon number 3. So the methyl group is at position number 3. So 3-methyl butan 1-ol. Okay, that's going to be the naming. Isophenol is liquid. Nickel acts as catalyst. Nickel is metal. So therefore they are solid. Okay, identify the type of catalyst shown. Okay, this one, okay, please go and read. We have 2 types of catalysts, homogeneous catalyst and heterogeneous catalyst. If you have different state, okay, this one is going to be heterogeneous catalyst. If you have nitrogen plus hydrogen to give you ammonia, okay, that is going to be if you are using the catalyst, okay, the catalyst for this gas. Okay, what is the catalyst for Haber process, Charlton?
Iron.
Don't know.
Iron, I think. Haber.
Jody, is it correct?
Yes.
Yeah, so it's iron powder. Okay, you must actually be very sure on this. So the iron powder is going to be solid. The rest are going to be gas. Similar to this, a different state that is involved. Okay, therefore this is known as heterogeneous catalyst. Okay, there is also homogeneous catalyst. Okay, please actually go and read on this. Now, draw skeletal formula of Q and suggest one commercial use of Q. Okay, so I need to find out what is this ester. Okay, so in order, I think to be easier, normally what I do, I just put the displayed formula. Okay, easier for me to draw. Okay, I'll put C. Sorry. Okay, C, 4C, 1C here, double bond, OH. Okay, so I want to actually react, okay, with C2H5OH, C2H5, H5, I put OH here. So what happens is, okay, the H comes from here, OH comes over here. So the ester that I will have C, double bond, and then there's C over here, join with O, and then C2H5. Now I need to actually draw this in form of skeletal formula. So 1, 2, 3, 4, 1 carbon, 2 carbon, 3 carbon, 4 carbon. After fourth carbon, there is double bond, double bond. After that, there is O, that's O. Then C2H5 means C2H5 is like this. So another 2, okay, 1 carbon, another 1 more carbon. Okay, I do not draw the hydrogen, so I just leave it like this, but do not forget about this carbon. Okay, at carbon number 2, there is another carbon. At carbon number 2, there's another carbon. So this is the only answer that is going to be accepted. There is no other way. Okay, the commercial use, okay, Q is ester. Okay, if you want to use it commercially, I think we use it for perfume industry. Okay, solvent. Okay, but I think you need to, whenever they ask you, please actually just answer. For ester, it's going to be perfume. Yeah, perfume. So far I've covered all this. Okay, please actually check as well. I have written some notes. Okay, I think I went through this. I have written some notes about carbonyl compounds. Carbonyl compounds, they react with 2,4-DNPH. They do react with Tollens region. Okay, silver nitrate and excess of ammonia. Yes, that will actually give you the silver mirror test. Okay, which one will actually give you the silver mirror test? Okay, this one, both of them must be aldehyde. Okay, aldehyde give you positive results. Okay, ketone gives you a negative result. Phthalate, okay, it's going to be alkaline copper 2+. Okay, the color change if you use aldehyde, you will change from blue to become orange. Okay, this one will be deep orange. This one will give you the mirror. This one is yellow precipitate. Okay, triiodomethane. So please go and read about this. Triiodomethane, you can have 2 conditions. As long that they have CH3 over there, they can actually detect. Okay, how they detect, okay, how do they write the equation? Please go and read. Okay, if you lazy to read, okay, please go and go through the video. I have actually recorded this video some time back, 2 years ago. Okay, so the audio might not be clear as well, but doesn't matter. The important thing is you guys go through that. Okay, and then the last reaction for carbonyl compound is going to be, they can be reduced. It means the carbonyl compounds, okay, they can be reduced to become, like for example, aldehyde, they can be reduced to become primary alcohol. If you have ketone, they will be reduced to become secondary alcohol. How to reduce them? You can either use alkaline NaBH4 or LiAlH4 in dry ether. There is another reaction also, which is going to be a nucleophilic addition reaction with HCN. You need to know the mechanism. Please, all this I have covered in the video. Okay, please go through that. And then the part, okay, I even actually wrote about, okay, the SN1 and SN2 also in the video. Okay, separate video where SN1, okay, is for tertiary halogenoalkanes. SN2 is more for primary halogenoalkanes. Okay, it's more towards to form tertiary, means they will form carbocation. If it is primary, then they will form intermediate. Okay, the rest you please read. Okay, please read. Okay, now let's actually continue. Now you have this P. Okay, the P can be produced as shown. So you have something like this. When they react with HCl, what happens? Okay, is going to be the double bond is going to be broken. So you have H and Cl, okay, being added. So this one, if they ask you the mechanism of the reaction, this is going to be definitely electrophilic addition. Okay, so any reaction that involves breaking the double bond is electrophilic addition. Now this halogenoalkane now become a nitrile. Okay, so halogenoalkane, when they change into nitrile, it means they react with KCN, okay, and then reflux. Okay, and this KCN must be ethanolic also. Okay, with alcohol. Okay, ethanol. And once you get that, this nitrile, yeah.
Can I go to the toilet?
Yeah. This nitrile, okay, they can actually undergo hydrolysis, okay. And once they undergo hydrolysis, they can also change into carboxylic acid, okay. So that is also one of the reaction to produce carboxylic acid. Okay, so please actually go through all this. Okay, but again, they say that the progress of reaction 1 can be monitored using IR spectroscopy. One absorption can be to monitor is when you have CCl. So there is going to be absorption as 730. Now they ask you to identify another absorption that you can use. Now the best absorption that you can use over here is, okay, there is only two things that is happening. The Cl is coming over. Another one, the double bond is going to go missing. So you need to actually just say, the carbon-carbon double bond absorption will disappear. So you need to actually find out what is going to be the carbon-carbon double bond absorption. So in order to do that, go to your data booklet, okay, and you will get the data. So let's actually, okay, you will get your data over here, which is going to be carbon-carbon double bond is going to go missing. So you need to actually put this absorption range will disappear, 1,500 to 1,680. Okay, 1,500 to 1,680. Hold on. So 1,500 to 1,680 cm negative 1 will not be there. Okay, that is actually one absorption that we can actually use, okay, to track the progress, okay, if there is a reaction. Yeah, so you must mention about this, you must mention about this. Now state the regions needed, okay, for reaction 2. Now, so I already put, okay, KCN, okay, reflux with ethanol. So the region will be, you can write ethanolic potassium potassium cyanide. Since they say state, okay, they didn't actually say name, okay, I'm very sure you can actually write down in ethanolic KCN. It's still accepted, okay, unless they say name, that's different. Now name the type of the reaction that occurs in reaction 3. So this one is going to be that the triple bond is going to be broken, and you are going to have the carboxylic acid coming in. So that is going to be you break using water. Okay, that's going to be you react with H plus and H2O. You're breaking using water. So this one is hydrolysis. Since it's going to use acid, if you want to mention acid hydrolysis, is still fine. If you mention hydrolysis, is good enough already. Now the yield of the reaction 1 is very slow. Explain why. Okay, so it means the yield over here, if I have the reaction, so carbon, and then I have double bond, okay, over here. So what happens here is they have changed from here to become, okay, this is CH3, CH3. So you have CH3, CH3, single bond. Okay, it means one H come over here, another Cl went over there. So it means carbon H, Cl. This is H. So I put the CH3 here. Now what happens here over is, okay, normally there will be two ways where this thing can happen. It means that HCl, the H can come over here or the H can come over here. Okay, in this case, what happened was the H went here, Cl went here. Instead of having the Cl going here and H over here, they mentioned that this one is much more slower. Let's actually identify what will be the reason why they say it might be slower. Okay, so let's actually identify what type of carbocation that is being formed over here. In this case, the H went here. Okay, so it means what happens here is CH3, H went here, and then CH, and then you have a carbocation over there. Now, what happens here is you are forming, okay, a primary carbocation. Okay, you're forming a primary carbocation. If it is the other way around, if the H came over here, you will get something like this, H, H, H. And then you have C, CH3, CH3, and then a carbocation over here. Now, this is going to be a tertiary carbocation. Now, instead of forming a tertiary carbocation, a primary carbocation is formed. Okay, so it means that, okay, this is going to be not a stable intermediate. It means a primary carbocation is formed, and it is not stable. Now, what actually stabilizes this? Okay, normally the one that will stabilize this is going to be the alkyl group. Okay, so less alkyl group, okay, less alkyl groups have less, what we call, they will donate the electron, yeah, they will push the electron over there. So it means they have less inductive effect. Okay, so this is something new, yeah. Okay, they have less inductive effect. Okay, less alkyl groups have less inductive effect. Therefore, okay, the intermediate is not stable. Since it's not stable, okay, they actually become less reactive. Okay, it means not stable means you are not going to form this intermediate easily. So if it is, this one is not formed easily, it means the reactivity is also going to be not so good. Okay, it's not going to react very fast. So this one, I want you to actually focus on this inductive effect. Now, if your tertiary carbocation is more stable, okay, compared to primary carbocation, okay, not stable. But now I'm introducing this term called, okay, if you have tertiary, it means the alkyl group have positive inductive effect. So I will actually put it over here, positive inductive effect. Positive means they will donate the electron. So when they donate electron, they will cause more positive. Okay, they will cause they will actually make the electron, the negative charge, to become more positive. Okay, so it's going to actually what we call a positive inductive effect. Okay, so now you have less positive inductive effect. Okay, if you have questions on this inductive effect, please actually ask me later. Okay, but you need to mention about this inductive effect, okay, in order to get the two marks over there. I have also written some other information about carboxylic acid, which you can actually use, okay, to revise. Okay, so this one, okay, I have actually completed this question, and there's a lot of things that you can learn from this. Okay, so as I told you, you can learn a lot of things. Okay, definitely a lot of things you can learn from here. Okay, so if you have questions, okay, please ask me. But of course, today I want all of you to go through the video that I have actually sent the link. Okay, because it covers all the things that we have discussed over here. So I want you, using this question, I want you to improve on the concept part. Okay, get all the types of reactions. If you need to write it down, please write it down somewhere. If you need to open the book, okay, and revise, please revise it somewhere. Is that okay, guys? Okay, that's all. Okay, see you guys. Okay, so